Many times we've been on shows where we need a low-cost laser projector to use as a monitor, maybe away from the actual show site. And the problem is that the low-cost, low-power laser projectors that are available on the market just don't have the quality of optical scanning that you need for a professional production.
When you're new to the laser industry, there's a lot of highly technical things which can be difficult to understand at first. One of the most complex is scan speeds. You would trust that your laser projector manufacturer would provide you with all of the details and 100% accurate information, or at least you compare specifications online and choose the company with the best specs. But it's not that easy, and in many cases specifications can be altered to make a given product appear to be better, or salespeople just tell you what it is you want to hear, not what's 100% correct. In today's competitive marketplace, this is becoming more and more of an issue. So you're left at the mercy of your manufacturer, in the hope that the optical scanning system you get inside of your projector does everything that you want it to do.
As a laser system manufacturer, we realize that the consumer market is growing pretty fast, as well as a customer demand on higher quality of low-cost laser projectors. The new range of laser diodes allowed us to steer our production towards these market needs, but the good quality and reasonable price scanning system was always an issue. The price of quality scanning system was very often higher than what we wanted to charge the customer for complete laser projectors, leaving us with the frustration of many lost business opportunities.
You know, when we introduced QuickShow, it enabled us to get into a portion of the consumer level market. Oftentimes, people would acquire a low-cost projector along with QuickShow and then be unsatisfied with the results. Now, because we wanted to solve that problem, we had to come up with an entirely new way of constructing a galvo, and I'll show you how it works. What we do is we take a laminated stack like this, which is inexpensive to produce. We put on it inexpensive preformed coils which are held in place with these inexpensive Kapton liners. You add a top and a bottom to that, like this, and it just all screws together. It's all held together with screws, and you've got yourself a scanner. So now to that we add a rotor and a position sensor, and our rotor and position sensor are great. The rotor is small enough to move small mirrors at speeds up to 50K, and yet still strong enough to move mirrors up to 1 inch without even requiring a notch filter in the servo. And our position sensor produces 10 times as much signal as that of a low-cost conventional galvo. Now this gives crisp, clean graphics. Now, the bottom line is performance that's on par with the most expensive scanners made in the world, but at a cost that is as little as 1/10 of that when purchased in volume.
When developing the Compact 506, we realized it presented a unique opportunity to further grow the laser industry. Our technology allows us to work with system manufacturers to integrate a low-cost, high-performance optical scanner while still maintaining an affordable price point. This makes projectors more appealing to both professional laserists and the rapidly growing consumer-level market, a market our industry has just only begun to explore. As a result, we're confident that we will see new types of laser projector systems being developed, as well as witnessing lasers being used across a much wider spectrum of applications. It's a very exciting time, and we're very optimistic for what the future will hold.